Okay, so before starting to our session, let me give you guys a brief introduction about myself. My name is Ashish Dhyani. I'm working as a trainer at Infosec Train, and it's been a decent amount of time that I have been working into the field of cybersecurity. Like when I started into cybersecurity, it was really new. Like still, cybersecurity is in uh, like growing stage, but at that time it was in a very infant stage, right? So when I started, before that, I was not working into cybersecurity. I was not learning cybersecurity. I was working into data science field. Then I got to know about cybersecurity. I moved to cybersecurity and I did some certifications. So the certifications that I did, I wanted to start from the scratch. So that's why I got to know whenever you want to go into cybersecurity. So you have two things in common. There are two things that you should know. First one is networks, right? The networking part. And the other one is Linux. So that's a bit of description about me. Now when we are talking about uh, CCNA, right? So CCNA is what? We have to understand the very first thing is what is CCNA exactly, right? So the agenda for today, the like this webinar is for 2 days, 2 hours per day, right? And the agenda for today is what is CCNA. Then we'll be discussing about VLANs, virtual local area networks, and spanning tree protocols, right? Now let's start with what is CCNA. Now what do you guys know about CCNA? CCNA, it stands for Cisco Certified Network Associate, right? So there is an organization, Cisco, which develops or manufactures Cisco systems, like your routers, switches, firewalls, lots of things, security devices, and the networking devices they manufacture. So they have their own certification, which is with the name CCNA, the associate level, the entry level certification, right? It is CCNA, right? Now why they have created this certification? Because all the devices that you have, right, all the devices, networking devices of other vendors that you are using, those devices, they have different protocol as compared to Cisco devices, they follow different protocol, and those devices, they follow some different protocols, right? So Cisco have their own protocols. So that's why they have designed a certification to validate your knowledge or any individual's knowledge that they can work with the devices of Cisco, right? So that's why CCNA was the first certification which was created. So it is a vendor based certification. So it is just for the people who are working into Cisco devices, who are working with the Cisco devices, right? For only those this certification is, right? And it is, as I said, associate level certification, so entry level certification it is. After this there will be CCNP, which is professional, and CCIE, right? Great. Now when we are talking about CCNA, so CCNA is now a single certification, right? But before, what was happening? Before, there was CCNA, routing and switching, where you will just learn about routing and switching. Then there was CCNA security as well, right? So many of you might have done that CCNA security, which was just giving you the information about the security part of the devices, right? There was CCNA wireless as well, there was CCNA data center as well, CCNA cloud as well, CCNA service provider as well, CCNA collaboration as well, right? So all these things, those were different types of CCNA certifications, right? So according to your job role, according to the things that you have, according to the whatever you are doing or whatever you want to work with, you can opt for the type of certification you are doing, right? If you are working with the wireless devices, you will go for CCNA wireless, right? If you are working with let's say the data center, so you want to learn the data center technologies, so you can go with CCNA data center certification, right? So all those are the certifications that you can go for. Clear? Now what is happening? Now CCNA is changed. The new CCNA that we have, it is a combination of all. Yes. So combination means it has security, it has a word about wireless as well, it has the word information about the automation as well, the programmability, the cloud, right? Routing, switching, the cyber operations as well. Everything is there, right? The CCNA, right? Now, the next thing is importance. What is the importance of CCNA networking? How it will help you, right? So when we are talking about the CCNA, it is giving you the understanding of the networking fundamentals. So we are gonna start from like the OSI model, the TCP/IP model, what is server, what is client, how client peer-to-peer model is working, how client server model is working, which one of them is best. From there we are starting, and then we are gonna learn about the different protocols like FTP, FTPS, SFTP, so how these protocols are working. And uh, now if these protocols are working, so how you can make safeguard these protocols, because security is also included in this CCNA certification, right? Now after that you will learn about IP addressing, the subnetting, the routing, switching, right? And all the Cisco technologies, not only like it's specific to vendor Cisco, but when we are talking about the technologies, some of the technologies are same, right, in all the other devices as well and Cisco as well. So at those times it will give you the understanding that how the protocols are working, because the BGP is same, right? If we talk about the BGP, border gateway protocol, it is same for the other internet as well, for the Cis- Cisco devices as well, right? So that is one thing which we have as in CCNA, right? Now someone asked me that does CCNA helps anyone who is stepping into cybersecurity field? Surely it will help you, because as I said, the first thing you will need is networking. Now if you have the in-depth idea of networks, which you only get in CCNA, right, then you can step into cybersecurity, right? You should know, like, not even leased lines are being used nowadays, but you should know about leased lines, what were leased lines, right? uh like we are using switches nowadays, like back in the old days in switches, when we used to uh configure the switches at that time, in configuration you need to check which wire is which colored wire will be connected to which pin number, right? This time you don't have to do that, because there is like this thing which is called auto MDIX in switches, right? Auto MDIX will help you in that. You don't have to take care of it, but still you should know, right? Same like that, you are getting to know the subnetting, the IP addressing, the routing, switching protocols, then how to safeguard them, how the security is given to the infrastructure, the network infrastructure, and everything, right? So that's why what we have, we need Cisco certification, the CCNA, if you are starting into security part, right? Now in networking also, like you are working into networking, you are network administrator, you are network engineer, how to handle all the things. It's a very vast course, right? So if you go to our website, if you check the course content, you will see that every single thing is written. So every single topic that you will be learning, every single topic is written. So it's a very vast course, right? Very big course, which will give you the information about every single part, like related to VPNs, the MPLs, the MTUs, everything, right? So that is what CCNA is, right? So it will help the networking professionals a lot, the professionals who want to step into cybersecurity. So this is the first step that I'll suggest you to take, right? If you are not good with networks, if you have very less idea about networks, so you can go for CCNA as well, right? Now, when we are talking about the topics that are included in CCNA, basically the domains of CCNA. So it is network fundamentals, the basics of networks, the network access you will be learning, the IP connectivity, that how IPs are working, how routing happens, right? And everything related to IPs. Then there is IP services as well, that what services IPs take and give, so what services you can take and what things you can change in your network related to IPs. Then there will be fundamentals of security. So if you are trying to move to the cyber security, right? Or you are trying to go into network security. So at that time you can go for CCNA. So it will give you the idea of basics of security, right? That how security is given, what are the secure protocols, what are the secure network devices, how to work with those secure network devices, right? All those things. Now after that you have automation and programmability, right? Now what is automation and programmability? In networking you have SDNs, software defined networking, right? So it uses software based controllers or application programming interface to communicate with the underlying hardware infrastructure, and you can direct the traffic on a network, right? So in that you have chef, right? Puppet, Ansible, different types of SDN languages you have, right? Now when we are talking about SDN, so for that, like, SDN gives you high speed, right? Then we have CDNs as well. So for all those things you will learn the programmability, how to do the programming in that, how to create SDN architecture, right? Everything will be included in the CCNA domain, the last domain, automation and programmability, right? So these are the topics which are included in CCNA certification. Perfect. So anyone can take the CCNA certification, either a person who is going into the networking field or a person who is going into the field of security, right? Great. Now we have the Cisco certification levels, right? Now, when we are talking about Cisco certification levels, right? So what we have CCENT, right? CCNT, Cisco Certified Entry Network Technician, right? Now, CCNT was a certification which was there long back, right? Now, this time, instead of CCNT, there is CCST. It's for the people who are working into the field of technician, right? Then there is CCNA, Cisco Certified Network Associate. Then there is CCNP, Cisco Certified Network Professional. So in networking, if you want to go one level up, right? Like you don't want to stay as a associate person, but you want to be a professional. Then you can go for CCNP. Then after that, if you want to be the expert of creating the networks, designing the networks, right? Cisco certified internetwork expert, right? Now in the exam of these certifications as well, what happens, you will get to create a network. So what you will be doing, you will be creating a network, and after creating a network you will be sending the data through and checking that if the data is properly being sent, what all protocols are being executed in between. So that it's a kind of uh, highest level certification if you in the Cisco field, right? So if you want to be the expert of networking, you can go for CCIE, right? Then after that, Cisco Certified Architect. Now, architect is the person you can say uh, the level of CISO, Chief Information Security Officer, right? So that is the person who just creates or design the network of the organization, right? So same like that, you have a CISO. So CISO will be having this kind of certifications as well, that how to design and architect the network, how to create the network of the organization, right? So these are the certification levels. We are going to discuss about VLAN, right? The introduction of VLANs, virtual local area network. Now, what do you think? What is VLAN? How will you define VLANs? So, VLAN, yes, it stands for virtual local area network. So, a virtual network created around the switches in LAN. Great. Now, when we are talking about VLAN, right? So, it is a virtual area network which allows us to create multiple local area networks with the help of a single switch. So, each VLAN, it creates its own broadcast domain. Anyone? Now, when I'm talking about broadcast, what is the meaning of broadcast? Yep, it will be a one to all communication, right? Now, when I'm talking about broadcast domain, so what happens? Let's say there is a switch, right? So let me share my other screen. Now, these are, let's say, these are three switches, right? This is switch one. Now, switch one is having some ports. Let's say it's a 48 port switch, right? Now it has 48 ports. So what will be the broadcast domain? Broadcast domain means how many devices at a single time can communicate with each other without any collision, right? So if it has 48 ports, so 48 will be the broadcast domain for this Perfect. Now, when we are talking about this 48 port switch, what I'm doing, I'm breaking the switch into virtual networks or virtual parts. It's just in the layman terms, I can say you are hammering down the switch and breaking it into different parts, right? So, if I break a switch and I create a local area network of 4 ports, right? 12 VLANs will be created, right? So, let's say there is switch 1, this is switch 2, and this is switch 3, right? So 15 devices, or let's say 12 devices are connected to switch 1, 12 devices are connected to switch 2, and 12 devices are connected to switch 3, right? So 36 devices, different networks they are. Yep, different IP addresses, different networks. Now instead of using 3 switches in my network, what I'm doing, I'm just using a single switch, so it will justify the cost as well. It will be cost effective also. So I'm just using one switch, and in one switch, I'm creating 3 VLANs, right? So let's say 1 and 2 and 3. Now these are the 3 VLANs that I have created. All these 3 VLANs, these are different networks, right? This is VLAN 1, right? This is VLAN 2, and there is VLAN 3 as well, right? So VLAN 1, VLAN 2, and VLAN 3, three different networks created in a single switch, right? If whenever they want to communicate with each other, that's a different scenario. But now in a single switch, I have created 3 networks, right? This is called virtual local area network. Virtually, you have broken down the switch into different parts. Now, when we are talking about this VLAN, so like there is a router. What router does? It will partition the network into local segments, and it will provide better administration, better security, and better management of the traffic. Now there should be a router, right? So if these are the VLANs which we have, VLAN 1, 2, 3, if they want to communicate with each other, it can happen only through a router which is connected to both, right? Now what is the main purpose of VLAN? Why we are creating VLAN? Just to save the cost, or is there any other uh like is there any other way? See, we are assuming that there were 12 devices connected to switch 1, 12 devices connected to switch 2, and 12 devices connected to switch 3, right? So what we did, we picked up a switch having 48 ports, a 48 port switch, and connected all the devices, created VLANs for them, different VLANs for them. Now, when we are talking about why we need to create different uh, VLANs, is that it can reduce congestion, right? So VLAN will create multiple broadcast domain. It will break the large network into smaller independent segments, so the traffic will get reduced. And also, VLAN will limit the user access to a certain network segment, which is then allowed only uh, to authorized users to have access to any network with highly sensitive information, right? So you can play with the access controls very easily when you are using VLAN. So VLAN you can use for different group of users as well, right? Different departments, different functions, right? So without needing to be in the same geographical area, VLANs can help to reduce IT cost, improve network security and performance, right? It also provides easier management as well, right? It to make sure or ensures network flexibility. So the ID of VLAN, right? VLAN ID, it is 12-bit long. That means it can create 4096, sorry, 94 VLANs. Now, each VLAN has only one VLAN ID. So for connecting multiple VLAN, we have to create multiple virtual switches. Clear? Now, the question here is, we know now about what is VLAN, virtual local area network. But there is one term which is local area network, right? What is LAN? If the connects. Yep. So when we're talking about local area network, it means that within a room or a building, if the devices are connected and communicating with each other, that is local area network, right? So what is the problem with local area network? Why we cannot create different uh like why we need VLAN? Like why didn't we worked with the local area networks only? We can have a small local area network, like I'll create a local area network with the name of marketing, a local area network with the name of sales, then there is a local area network with the name of a security team, right? For everyone I'll create a small local area network. So what is the problem in doing that? Why we created VLAN, virtual local area network? Okay, so what is the need? Why I cannot create two different local area networks, and why there is like LAN created? VLAN, the virtual one. Why need to create that? So in local area network, there were some problems, right? There was lack of isolation. Now, lack of isolation means group traffic is localized in local area network. So consider that there is a system, system 1, S1, from electrical engineering. They send a message to system S2 in electrical engineering. Now no other system will be involved. But the broadcast traffic, it is not localized. If S1 sends or S1 wants to broadcast a message in local area network, then all the systems in all department will receive it because the network is same. So we need to limit the scope of broadcast traffic in LAN, right? Due to security reasons. That was one problem. Then there was insufficient use of switches. Now there are departments, right? So the number of departments are more as compared to the systems in each department. So the switches required is very high, and this is really inefficient, right? Then the third one is user management, right? So when a user moves to another department, he or she needs to take care of the physical cabling as well, right? That's why we cannot create LAN, right? The subnetting cannot help or does not help, right? So we can apply the subnetting to solve the LAN problems which we are getting, like the lack of isolation or insufficient use of switches, right? But the devices in different physical locations, it cannot be in the same network, breaking the network. So subnet means creating sub parts of the network, small parts of the network, right? So that is what subnet is. Now, subnetting is not helping, but you are doing subnetting, which is solving the above problems, right? Then all devices in the subnet, they should be connected to a single switch, and it should be connected to a port in a router. So subnetting is not solving the LAN problems efficiently. So that's why we go for VLAN. Yes. Now VLAN, when we are talking about VLANs, so virtual it is, being such an effect but not actually existing, right? Virtual reality. So multiple VLANs can be defined over a single existing physical LAN. Great. Now when we are talking about VLANs, so they help you to enable the separation of different departments, different teams, or but it helps you in doing the isolation. Then VLANs, they will restrict the scope of broadcast traffic, so it will prevent it from spreading beyond the confines of the VLAN, right? The VLANs, they provide flexibility in reorganizing and expanding networks without physically relocating the devices, right? So that is, these are the uh, things that you get, the benefits of VLAN, right? Now in VLAN, you have logical segmentation, you have VLAN tags, port membership, trunk ports, right? You have broadcast isolation. So what are these? Now when I'm talking about VLAN, there are different types of VLANs, right? So there are what? There are three types of VLAN: port based VLAN, MAC address based VLAN, protocol based VLAN. Okay, let me tell you. Now the very first one is port based VLAN, right? So network admins, what they do, they divide the switch ports or interfaces into VLANs using switch management software, right? So undeclared ports, they belong to default VLAN, right? Now there is inter VLAN communication, right? So when we are talking about these port based VLAN, right? So what we have inter VLAN communication. Now how the communication, inter VLAN communication happens, right? So what we do, we'll connect, let's say, any unconfigured port to any external router. So same example, like there is an electrical department. So the IP datagram, the IP information from electrical department will reach the router. Then it will forward the datagram to computer science department, right? So nowadays what happens? Nowadays your single device, it acts as both VLAN switch and a VLAN router, right? You don't have to attach a separate router, but back in the old days, you need to have a separate router in between. Okay. Interconnecting VLAN switches, if users are not the part of VLAN, but they want to get connected to it, we need to connect two VLAN switches, right? So on each switch, you will assign distinct ports to each VLAN and interconnect them. Something like this. Yes, if you guys can see, this is a 8 port switch, this is a 16 port switch, and on every switch, the highlighted blue ports, which you can see, these ports are a part of VLAN. So one VLAN is in the bigger switch, one VLAN is in the uh, smaller switch, right? And then they have interconnected the switches from one port to another. So that's your interconnected VLAN switches, right? So ports required varies directly with VLANs, right? So whatever ports you require in VLANs, that is like it's a varying process, right? So to solve that process, we go for trunking. Now trunk, right? When we are talking about trunking, there is a term trunk. Trunk is what? Main big part of a system, right? So in every switch, there is a one port which acts as a trunk port, and it belongs to all virtual local area networks, right? So what we have this thing, right? This image, if you see in this image, what we have a trunk link in between. The trunk link allows the communication between two different VLANs, right? Then we have MAC address based VLAN. Now what MAC address based VLAN? MAC stands for Media Access Control, right? Now media access control, it is what? How will you define media access control? Like when we are talking about MAC, so we have MAC addresses. 48 bits address given by the vendor to your network interface card. So this is the physical address where exactly your device is in, right? So when we are talking about MAC address based VLAN, so it is also known as like hardware based VLAN, physical address based VLAN, Ethernet hardware based VLAN, right? So the network admins, what they do, they configure the VLANs based on MAC address using switch management software, right? And the reconfiguration is not needed, right? So the network, like different VLANs when we are talking about. So there you have what, like there is a disadvantage as well. Like we are working with MAC addresses, right? So the issues which arise when members of different VLAN exist on a single port of a switch. At that time, the clash happens. Yes. So that is MAC address based VLAN. Then we have network layer protocol based VLAN. Now, network layer protocol based VLAN will be working with IP address. Now, what IP address is? See, whenever you are configuring the VLAN, it's in the hands of the administrator only who can change the configuration. We can just send the data from one VLAN to another VLAN. So department A, you will not be able to change the configuration of department B, right? They cannot directly communicate with each other. What they are doing is they are just sending some data with the help of a router in between, right? So router will help them in routing the data, not accessing the configuration. Great. So when we are working with the IP addresses, right? IP address is the logical address of your network. That means the address which tells uh, that in which network you are sitting in. What we are doing in network layer protocol based VLAN, numerical label assigned to a device connected to a computer network that uses IP for communication. That is our IP address, right? So network administrators, what they do, they configure the VLANs based on IP address using switch management software, right? Now there is a need of VTP. VTP stands for VLAN Trunking Protocol. Yes. Now there is a need of VTP. So what we need to manually create VLANs on switches, right? To maintain VLAN connectivity between the trunk switches, right? So the problem is that manual configuration, it is time consuming and it is prone to errors. So what we do, we go for VTP, right? VTP, let me write it here. VTP, VLAN trunking protocol. Everyone? Correct. The data link layer is called the layer 2. So it is a layer 2 protocol, right? Now, when we are talking about VTP, so it maintains VLAN configuration consistency. So the changes made to single VTP server switch is propagated to all the trunk connected switches. Okay, if you see this image, now the very first step is what you do, VLAN is configured with a VTP switch, right? Now there is a switch, specific switch which follows VTP, right? Or which supports VTP. Now it is sent to all the switches which are connected to the VTP switch, right? Then all switches they synchronize the latest version of VLAN information, right? Now what is the VLAN information? So there is what? There are three modes of VTP switch, right? Now what are those three modes? These are the three modes, right? Server mode, client mode, transparent mode. Now in server mode, sends and forwards VTP advertisement. Client mode, send forward VTP advertisement, right? So what we have the frame format like the advertisement will contain VLAN configuration information, right? Then there will be followers, there will be updater identity, there will be update timestamp, there will be MD5 digest value, right? All over the VLAN, there will be management domain as well. So there will be a different kind of you can say fields, right? Lots of fields will be there. Now the thing is, the VTP will do what? It will, the advertisements that we are talking about, these advertisements are sent over a default VLAN using multicast frames every 5 minutes when a change occurs, right? Now, when a VTP ad is received, the switch checks the management domain name and the password, which is followed by configuration revision number. If the received configuration revision number is greater than its own configuration revision number, it means that the update has to be made, right? So the switch will synchronize its configuration accordingly and will make the changes. Hyper-V, do you guys know what is Hyper-V? It's a virtualization software. Yes. Now what Hyper-V is given by Microsoft, right? So it is just nothing but a virtualization software which allows you to have multiple virtual operating systems inside your device, right? So what you can do using Hyper-V managers, you can easily create or delete virtual network adapter as well as virtual switches. So it allows you to increase or decrease the scale of your virtual networks on demand, right? Now when you are connecting an existing VLAN on a physical network or to a virtual network, it needs the to create an external virtual switch. So in Hyper-V, an external virtual switch, it binds to a physical network adapter and it connects the physical network to virtual network segment, right? Then there is a word. Now with VLAN, what you can do, you can create maximum 4094 VLANs. But what if we want more VLAN? Then you use VXLAN. Now VXLAN is what? It stands for Virtual Extensible LAN, right? So it uses 24 bits to represent VLAN ID, which scales it up to 16 million VLAN segments, right? Now, in data centers, whenever we are working, VXLAN is the most commonly used protocol to create the networks and the overlay networks which will sit on the top of physical network. And it also enables the use of virtual network of switches, routers, firewalls, load balancers, and so on. So the VXLAN protocol, it supports the virtualization of data center network and it addresses the need of multi-tenant data centers by providing the necessary segmentation on a very large scale, right? That's why we need VXLAN. Clear? Now, if I talk in terms of security, right? What are the attacks that can happen on VLANs? I'm configuring my own network to act as a switch. And because most of the switches they are set to auto setting, the attacker can gain access to the trunk by attempting to form a trunk, right? So the best way to prevent this is to disable trunking on all ports, right? Save for the ones which actually need it, right? Then there can be, so it is an important characteristics which comes from this. That is, uh, this attack can happen regardless of trunking protocols or properties in any switch. To make sure that this doesn't happen, is you can ensure that the native VLAN of the trunk port is different from the VLAN of user ports, right? So just make sure the like the protocol or the ports that you are using, they are different from each other, right? So a very good security practice is to use when working with the VLAN is to separate the traffic of management data and the user data, right? Often what people do, they change the VLAN of the management, right? So that's not something you should do. So that is what, that is your VLAN, right? Now when we are talking about the routing and VLAN, so we have inter VLAN routing and VLAN interfaces, right? So inter VLAN routing is the process of enabling communication between different VLANs using a layer 3 device, right? Like router or switch, right? Now VLAN interfaces, when we are talking about VLAN interfaces, are your virtual interfaces which are configured on a layer 3 device, which will allow the traffic to pass between the different VLANs, right? Now the next thing that we have is spanning tree protocol, right? Now how will you define spanning tree protocol, what it is? Okay, now when we are talking about spanning tree protocol, it is a layer 2 management protocol. So what it does, it eliminates the network or layer 2 loop by selectively blocking the redundant links, right? Now what can be redundant links? How will you define redundant links? How will you define hot standby link? Or I can say, to reach any destination I have two different paths, two different ways, right? Those are known as redundant links, right? So what it does, it basically blocks the redundant links, right? Now since the spanning tree protocol itself is very small, it's not uh, well known as your routing protocols. So it is in charge of port forwarding power, right? When running other protocols, spanning tree may break the message path for other protocols, which will cause all kinds of strange phenomena, right? Now, spanning tree protocol, like other protocol, it is constantly being updated because network continues to evolve, right? So it is the title, in the title of this thing, spanning tree protocol, it does not specifically refer to the spanning tree protocol, right? So once when it was started with IEEE 802.1d protocol, right? But it includes STP and various spanning tree protocols that have been improved on the basis of STP. So in the development of spanning tree protocol, old defects they are constantly being overcome, right? New features are being developed every day, right? So when talking about the spanning tree protocol, whenever we design a local network, most of the time we'll come across a scenario where we will be having several switches. Yep. So what will happen? You will get a scenario where you will see that there are multiple switches. So with a very simple and common purpose, the switches can fail, right? It can become inoperative, which will leave the network unavailable indefinitely. And it may also have failed at the physical layer, where cables may be broken or unplugged. But if there are redundant switches and links, the network service will still be available, right? That's what happens actually, right? We always take a backup, or we'll have a backup plan for it. So we keep two switches, like if one switch fails, we'll quickly replace with the second switch, right? So if the spanning tree protocol did not exist, the frames sent would be in an infinite loop in a scenario with physically redundant links, right? So for this frame loop to be avoided, right, the spanning tree blocks some ports and it prevents them from resending the frames, so that it has only one path between, right, any segment pairs, right? So whenever there are two switches communicating with each other, right, so there will be the blocking state, right? Let me show you with the help of a picture. Now what happens is, let's assume that, right, this PC I have disconnected from the network, right? Now what we have, let's say this PC is disconnected from this network. This is PC A, this is PC B, and here this is PC C. Now from this PC A, I'm saying that I want to send data, so I sent a data for PC C, right? So I've sent data for PC C. Now that data is sent to first switch. This first switch did what? It broadcasted the data. Now the bad thing about switches is, whenever they don't know where exactly the thing is, uh, where exactly the data is, right? So at that time, switches, they start broadcasting the data, right? So this switch will broadcast the data to this switch. Now switch 1, which is this switch also does not know where exactly PCC is, so it will also broadcast the data. And this time this switch does not also know where PCC is, so it will also broadcast the data. So that broadcasting data will keep on traveling in a loop in this network, right? And the switches will crash. Yes. Now for this problem, for mitigating this whole problem, what we do, we use spanning tree protocol, so that one of the redundant path, either this path or this path or this path, will be closed by the spanning tree protocol. Yes. Now what we have, whenever we are talking about this spanning tree protocol, right? So in this, it stands for bridge protocol data unit. What is BPDU? Okay. Now when we are talking about BPDU, right? What we have, BPDU means that these are the frames that will be sent over the whole network to all the switches, right? So there are two types of switches, right? Or bridge means a switch, right? In spanning tree protocol, we call bridge a switch. So there will be a root bridge, right? And others will be non-root bridges, right? Root bridge means it is the main switch in the STP, central switch. And non-root bridge, these are the other switches other than root bridge. So in every segment, there is one switch selected, which will be called designated bridge, right? It handles all the communication from local area network to root bridge, right? Then there is something known as bridge ID. So bridge ID, it is the identity of the switch. It is an 8-byte value which includes bridge priority and MAC address, right? So bridge priority is of two types, MAC address, as you know, it is of 6 bytes, right? So bridge ID, it is very important during the STP operation. So whenever we are selecting the root bridge, right? So what will happen, right? These are my three switches. Now every switch is saying that I am the root, I am the root, right? So how it is done? It is automatically done by STP with bridge ID values, or we can manipulate root bridge selection to select an optimum switch, right? Second way is always a good configuration habit, because if a low capacity switch becomes the root bridge, the network can be affected very badly. So we can configure a specific switch as a root switch in some vendors, right? Now another and most common way to do is manipulating the bridge IDs. So bridge ID consists of bridge priority and MAC address. So we cannot change the MAC address. So we can change this by changing the bridge priority values, right? So the default priority is 32768, and setting the lowest priority on a switch will provide this switch to be a root switch. So in a root selection process, all the switches, they announce that the root bridge is itself, that I am the root bridge, right? Now here the switch that has the lowest root bridge ID is selected as the root bridge, right? So the priority plus the MAC address. Now whatever the output is, out of all of them, they will configure and they will calculate the output, right? Once they have calculated the output, then they will find out which one has the lowest bridge ID, right? So once the lowest bridge ID is found, that switch becomes the root switch, right? Let's say this switch 1 becomes the root switch. Then what next thing we have is, the next thing is the port rules. There are different ports. So in spanning tree protocol, you have port rules, right? Now when we are talking about the port rules, root port, right? Then there will be designated port, and then there will be non-designated port, right? Now root port is the port that connects a switch to the root bridge with lowest path cost, right? So you don't have to travel that much, but it will be connecting you to the root port, root switch, or the root bridge. Designated port is the port which will connect a switch to a non-root segment. So designated ports are the ports which are open ports through which the data can travel, right? That's what is the meaning of designated port. And then we have non-designated port. Now non-designated port is what? It is the port which is in other port than the designated port in a segment, right? That means the blocked port, right? So the ports which will be blocked for having no redundant links, right? That will be non-designated port. Clear? So the port selection, how the port selection is done. When we are talking about port selection in the bridge, right, or in spanning tree protocol, right, at that time first your root bridge will be selected, then root ports on all the switches will be selected, then designated ports will be selected, and lastly the non-designated ports will be selected, right. Then all switches in the switch domain, they have one root port, right? So the port of a switch that connects a switch to non-root segment will be selected at as designated port. So this is done by selecting a designated switch in that segment. Perfect. So these are all the things which will be happening, right? Now what we have the states, right? So spanning tree protocol, how it works, these are the bridge protocol data unit, the redundant links are there, right? The path cost, the blocked ports, right? Everything is there. So the election, everything is happening, right? Now, when we are talking about these, the algorithm, right? So what do you have? Like there are port states, first thing. So in port states, what we have disabled state, right? Then there is listening state. Then there is learning state, right? Then again, it will be learning state only for again 15 seconds. Then forwarding state, and then blocking state, right? So the thing is that disabled state means it is the state that means the port has not enabled yet. So it also implies a failed port. Listening state is the state in which the root bridge and port rules are determined by sending and receiving the BPDUs, right? Learning state is the state in that MAC table is filled with the learned addresses, right? Then there is forwarding state, the state that port has started to forwarding the frames. Then there is blocking state. Blocking state is non-transmitting state. This is the port that is selected as non-designated port, right? So it can listen and forward BPDUs, but it cannot forward the frames. So it cannot forward the data. Yep. So these are the states. Now, what we have types of spanning tree protocol, right? So there is a rapid spanning tree protocol, RSTP. Heard of it? Now, when we are talking about rapid spanning tree protocol, right? So it has like same things will happen. Root bridge, root switch, root port, designated port, non-designated ports will be found. But it will prevent network loops, prevent the redundancy, same, but it has faster convergence, right? In this state, it will be from disable state to learning state and then forwarding state and blocking state, right? So the states will be less in this, right? That is what? That is your rapid spanning tree protocol. Now, what do you think, guys? Whenever we are using spanning tree protocol, so the bandwidth utilization will be less because redundant path will be less, and it also depends on the fiber cable, if you are using the fiber cable, so it will not increase the burden. But if only one cable or one path is carrying all the data, right? So that, let's say there is a switch 1 which is known as root bridge, right? Then there is switch 2 which is like one of the port of that switch 2 is blocked. So in this case, the fiber laid between the switch 3 and switch 2 will not carry any traffic, and all traffic which switch 3 and switch 2 will be forwarded, it will be forwarded through switch 1 and switch 2, right? So it will increase the burden on other links, right? So the data, like let's say in simple terms, this link is a redundant link, close that. So if there is some data for switch 3, the data will be sent through here. If there is some data for switch 1, it will be sent through here, right? So the data, it will increase the bandwidth utilization. Yes or no? So it will increase the burden on other links, right? So using STP, you cannot overcome the bandwidth utilization, right? So that's what your spanning tree protocol is, right? So this was it for today, guys.